Hi everyone, welcome to my channel. Please like and subscribe. In this video, we'll be learning how to lead floor beam structural drawing. Now let's start step by step. First of all, let's check this floor layout plan. This floor layout plan helps us to know where each beam is located, and this floor layout plan helps to identify grid lines. This grid line passes at the center. This grid line passes at the center of each columns. These are grid lines. They are located horizontally and vertically. For instance, horizontally they are labeled in numbers. Let's say this is number 1, number 2, number 3, up to 11. And vertically they are labeled in alphabetically. They are labeled from A, grid line B, grid line C, up to grid line H. This is grid line H. Also, this flow layout plan helps us to identify the position of columns. So these symbols used to identify the position of columns. So the column should be placed at this point, 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 and of all of the whole this layout plan. Also, this layout plan help us to identify the location of staircase. As we see in this layout plan, the staircase should be placed at this region. Also, this layout plan help us to identify the location of beams. These are beams with its dimension. All of these are beams, long beams, short beams. All of these beams have its dimension of 230 millimeter by 450 millimeter. All of these beams have its unique identification. This unique identification is known as beam mark. Now, let's check. This is beam mark number 1, which starts from grid line number 1 up to grid line number 11. Also, this is beam mark number 2, beam mark number 3, beam mark number 4, beam mark number 5, beam mark number 6. This is beam mark number 7, beam mark number 11, beam mark number 9, beam mark number 10, beam mark number 11, beam mark number 12, up to beam mark number 6, beam mark number 16. This is beam mark number 16. This beam mark corresponds to the reinforcement details. So all of this beam mark correspond to the reinforcement detail. Now let's check the reinforcement detail. The reinforcement details are this one. For instance, this is reinforcement details for beam mark number 1 and 2. Beam mark number 1 and 2. So this is beam mark number 1 and this is beam mark number 2. Its reinforcement details are shown at this beam elevation. So also this is reinforcement detail for beam mark number 3, 4, 5, 6, and 8. Also this is reinforcement detail for beam mark number 9. For beam mark number 9. So this is known as beam elevation and this is known as beam section. All of this is reinforcement details. Now let's check this beam mark number 1 and beam mark number 2, which its beam dimension is 230 millimeter by 450 millimeter. This beam elevation have arrows. As you see these arrows used to explain beam section. So for instance, these arrows show section 1-1, section 1-1, which is this one. This is section 1-1. Also these arrows show section 2-2, which is this one. This is section 2-2. Also, this beam mark number 1 and 2, it have section 3-3, which is this one. Section 3-3, which is this one. Now let's check the details in this beam section, which is section 1.1, section 2.2, and section 3.3. Let's start with section 1.1. Section 1.1, it have a beam dimension of 230 millimeter, which is the width of the beam, and it have the depth of and it have a depth of 30 millimeter from this point up to this point, which is a depth of the beam, and it have a thickness of the slab which is 150 millimeter. This is the thickness of the slab. This is the thickness of the slab from this point to this point. Now, this beam section might have two zones where reinforcements should be placed. Bottom zones where tension reinforcement should be placed, and top zones where compression reinforcement should be placed. Now, at the bottom, there should be three bars with a diameter of 16 millimeter at bar mark number 1. As you see here, this is the first main bars, the second bars, the third bars at bar mark number 1. And at the top, there should be two main bars with diameter of 16 millimeter at bar mark number 1. So this is the first main bars, and this is the second main bars, and one extra bars of 16 millimeter at bar mark number 4. This extra bars is located over supports for negative moments. These extra bars do not provided over the whole length of the beam. Instead, they are provided only where additional strength is required. Now, let's check also. Also, this beam section, it have shearings, sometimes known as stirrups, with a diameter of 8 millimeter at bar mark number 2, at a spacing of 200 millimeter. Also, let's check section 2.2. This is section 2.2. Section 2.2 have also the dimension of 200 millimeter, which is width, and depth of 300 millimeter depth of the beam, and the thickness of the slab is 150 millimeter. At the bottom, there should be four bars with a diameter of 16 millimeter at bar mark number 1. So the first bars, the second bars, the third bars, and this is the fourth bars at bar mark number 1. And at the top, there is two main bars with a diameter of 16 millimeter at bar mark number 1. So the first bars, the second bars. So this section 2.2 have no extra bars. Now let's check section 3.3. Section 3.3, also at the bottom, it have four bars with a diameter of 16 millimeter at bar mark number 1. And at the top, there is two main bars with diameter of 16 millimeter at bar mark number 1. So the first main bars, the second main bars, and the two additional or extra bars over supports for negative moment, which is lies two extra bars with diameter of 16 millimeter at bar mark number 4. The first extra bar, the second extra bar. So these extra bars are not provided over the whole length of the beam. Instead, they are provided only where additional lengths should be required. For instance, from this section 1, section 2, and section 3, as we see, section 1 and section 3 have only extra bars where is required. As we see in our beam elevations, these extra bars are placed over supports for negative moments. As we see, this is beam elevation for beam mark number 9 over supports. As we see, this is section 3C, is where extra bars is required, and that this shows us at over supports, it have section 1.1 is where extra bars is required, and at this beam elevation shows that this is section 1.1 is where extra bars is required, and this is for beam elevation for beam mark number 1 and 2 over support shows that this is section 1.1 is where extra bars is required. Thank you for watching this video. Please like and subscribe for more civil engineering content, especially for the next video. Thank you. See you.